want to kind of unlock. Tomorrow will be our big day on T's. Today is just a tease of the T's. See what I did there? All right. Z's. At this point of the game, Z's in confidence intervals and hypothesis testing go with proportions. And T's in confidence intervals and hypothesis testing will go with means. Okay? That should not be new information to you. Today, again, the requirements, always independent, random, and normal. We'll discuss the way we check for normality here. It's going to be very similar to what we did with the confidence intervals. So it's just more of the same. For T's and hypothesis testing, it's going to be the same 8 steps. The only difference is you're going to use a T statistic instead of a Z statistic. You're still going to, in step 6, you're going to say, step 5, you're going to explain why you're doing what you're doing. There is one red flag, gray area, if you want to call it gray, and I want to talk about it. I have never seen it assessed on the free response. I have seen it assessed on the multiple choice. Okay? So we know Z's at this point. You guys just got a quiz on it. How to do those 8 steps and what's needed, independent, random, normal for P's, what that looks like. For T's, independent, random, and normal, we should know what that looks like. Greater than or equal to 30, then we can apply the central limit theorem. So that's normality. Independence, less than 10% of the population. We're good there. And then random sampling. We're going to get into tomorrow what happens if we have a small sample size and they give us data points. We're going to have to look at that distribution and either use a box plot or a normal probability plot and then justify what we're doing. Now here's the gray red flag, or something I've seen on a multiple choice, but like I said, I haven't seen them do it on a free response for you. It is possible to do a one sample or a, I think it's one sample or just a z-test. It is possible to do a z-test, okay, with a mean. Again, it's possible to do a z-test with a mean. I will tell you, if you're going to err on the side of just memorizing something, always do a t with a mean, with a mu or a mean problem. The one time you will use a z-test instead of a t-test is when sigma is known. Okay? And I said, hey, just keep an eye out for that. Sigma, sometimes they'll say the population standard deviation is blank. If you know the population standard deviation, you'll use a z-test. It tends to show up maybe on a multiple choice test once every 3 or 4 years. It's a random situation. So I'm only going to talk about it today. Again, the big kind of connection piece, the Z's go with P's, T's go with means and mu's. Okay? The rare case that you might do a z-test is if you know sigma. But I would always argue if you know sigma, if this is known, then you also know that because you can't calculate that without knowing that. And if you know the population mean, why are you sampling from that population? You already know everything about that population. Does that make sense? So this is more of a theoretical than we actually use it and apply it, which is why I only want to talk about it here. What's that? Is there a question? All right, we got time for a quick one here. Teachers Union would like to establish that the average salary for high school teachers in a particular state is less than $32,500. A random sample of 100 public high school teachers in a particular state has a mean salary of $31,578. The sample standard deviation is $4,415. Test the union's claim at the 5% significance level. There's the problem. Right now, you guys as students should be able to tell this is no longer a proportion problem. It is a mean problem. Same 8 steps. We're talking about averages and means. They even give you standard deviations there. Define it, mu. Mu in this case is the true mean salary of high school teachers. Number 2, null hypothesis. Number 3, alternative. What is it we're trying to prove here? A teachers union would like to establish that the average salary for high school teachers in a particular state is less than $32,500. So that means we're testing the union's claim. We'd like to see evidence that the mean is less than $32,500. That's what we're trying to prove. Then our alternative hypothesis is going to be the equal sign. And that should follow. Yo.
Are we supposed to round it?
Round. Did I not? Gotcha. That's our average from the sample. Tested the 5% significance. So our alpha level is 0.05. And now we're at step 5. It's probably the most important step. If you don't get step 5 right, kind of less the problem goes kind of downhill. Okay? We are now doing a one sample t-test. We're doing a one sample t-test. We'll justify, bless you, the one sample t-test. Independent, random, and normal. Normality here is real easy. Our sample size is sufficiently large. Sufficiently large. I'll just say n greater than or equal to 30, because n equals 100, I think. So central limit theorem is applicable. Random. I think it said random in the problem. A random sample. So sample is random. That's just one sentence. Sample is random. Justify that. Bless you. Independent. We'll say that's definitely 100 is less than 10%. So independent sample is less than 10% of high school teachers. Again, we've justified why we're using that one sample t-test. The other thing I'm going to add right here is sigma is unknown. And again, 99% of the time, sigma is going to be unknown. And I told you that rare case, if they happen to tell you that the population standard deviation is, then you'll use a z. But like I said, I've never seen a free response on that. Step 5. Step 6. T-statistic is x bar minus mu over s of x over the square root of n. Should look familiar. Plugging in 31,578 minus 32,500 over 4,415 divided by the square root of 100. Again, we should see a lot of similarity between our proportions and our t's. Just a different statistic. The same 8 steps. And you can crunch that, I believe, comes to negative 2.08. Are we getting negative 2.08 for that? Okay. So now we need to get our p-value. And most of you guys are starting to figure out the pattern on this test. Stat. Bless you. Bless you again. Test. This is a very straightforward t-test. It's a plain, simple one sample t-test. We're going to take our data from the statistics that we have. We've got 32,500 as our mean. The average we're comparing it against is 31,578. The sample standard deviation was 4,415. And our sample size was 100. we're looking for evidence to say that the teaching salary is less than $32,500, so it's less than. And then we're going to hit calculate. The t-score is negative 2.08. Our p-value, we'll call it 0.02. We're going to round that to 0.02. So our p-value is approximately 0.02. The other thing that we need with the t-test is n-1 degrees of freedom. So I'll say with 99 degrees of freedom. Think about that if you're pulling it off the formula sheet. Your calculator will calculate the degrees of freedom for you. P-value is 0.02. And our p-value compared to the alpha value, 0.02 is less than or equal to 0.05. So that is a reject the null hypothesis. And then step 8, we're up against time. I'll say it orally, but it should make sense to you that step 8 will be, we are 95% confident that the true mean teaching salary of high school teachers is less than $32,500 at the 95% confidence level. Okay? Yes. Okay. Homework is posted on Blackboard.